Alright, so now I've started it. Proportions, word problems. The first thing we're going to do is an example. Because a lot of these I think you can kind of figure out without having me tell you a strategy. So we're going to do like, if 3 apples cost $6, how much would 12 apples? This should all be going into your notes, into your notebooks. Everyone should have their notebooks open. You should have a title, proportions, word problems at the top. And then just start out with this example. And write out that entire example in words. Okay? And I'm going to just show you how to do this. I'm going to show you my strategy. The first thing that we do when we have a word problem like this is we try to identify our 2 things that are being compared. So in this case, one thing is apples. The other thing is almost a little bit hidden, but it's pretty common. It's dollars. Right? Then what I like to do next is either in my head or on paper. I think about this. Okay, I'm going to make a proportion that shows apples to dollars. And in order for it to be a proportion, I'm going to have 2 different ratios. Now with these word problems, you'll always have a variable in one place. Okay? It also doesn't matter if you do it apples to dollars or dollars to apples. You get the same answer. As long as both sides of your proportion, both ratios, go the same way. So my first ratio is 3 apples to $6. 3 to 6. Am I doing this or this? The top or the bottom? Am I doing this ratio, apples to dollars, or dollars to apples? Apples over dollars, right? 3 apples, $6. Okay, equals. I have one more number, 12. Is that going to go in the numerator or denominator? Numerator. Numerator, because that's the number of apples. What am I going to put down here? Yeah, I'm going to put any variable. I might say C, because it's cost. Okay, it doesn't matter, but you could say any variable that you want, because we don't know how much 12 apples cost. So we use a variable for that. So 3 apples over $6, that's the first part, compared to 12 apples over an unknown. A variable is also called an unknown cost. Okay, first step. So I'm going to just remind you guys, I want you to put this in your notes, because some people skipped a couple steps here. So we have basically 4 steps for solving proportions. And I'm not saying this is the only way to solve a proportion, but I wouldn't leave out any of these steps. Okay, so the first step is reduce your fraction. Super, super, super important step. Second step, cross multiply. Third step, divide both sides.
Isn't it divide by the coefficient?
By the coefficient. Right? And if you don't remember what a coefficient is, make a note to yourself. Right? Your notes are supposed to be helpful to you. So if you don't know what a coefficient is, you should write a coefficient is the number in front of a variable. For example, 2x, 2 is the coefficient. And then what's the last step? This is something that some people forgot on their homework. You then need to reduce your fraction again. This time there's only one. That's kind of your answer. Some people left things like 30 halves on their homework. 30 halves is just 15, right? And so I want to see it in that simpler form. You do not have to simplify or convert your fractions though. So if you have like 9 halves, that's totally fine. You can leave it as 9 halves. You don't have to say whatever that would be, 4.5 or 4.5. All right. So now we've set up our proportion. We're going to follow those 4 steps. What can we reduce? If you look over on the left, there's something that these two numbers, there's a factor that 3 and 6 have in common, and it is 3. So we're going to reduce this one. We're going to write 1 over 2, because 3 divided by 3 is 1, and 6 divided by 3 is 2. Equals. When we have a variable, unless it has a coefficient, we usually can't reduce it, right? So 12 over c, we don't know c. So there's no way we know what factors go into it yet. So we're going to have to just leave that as 12 over c.
Do you have to simplify it?
No. But if you don't reduce it now, you'll have to reduce it later. So it's easier to do it here.
Also, just as another statement about that, if you didn't reduce it, suddenly you're looking at 3c is equal to, what's 6 times 12?
72.
72, right? So 3c equals 72. Well, not everybody knows there's 72 times tables. They don't. You know what I'm saying? It's so much easier if you're dealing with smaller numbers. So reducing is like a great gift that you're giving yourself because it makes it very easy to do it, right? Otherwise, you could potentially be doing, that's not too hard even if you multiply it out. But like, he could have given you 17 over 96 is equal to 264 over c. But if you multiplied those out, it would be a negative, right? See what I'm saying? So if you can simplify them somehow, it would be awesome.
Would it not be easier instead of like doing all this work, the proportions, to just divide 6 by 3 and then multiply the product by 12 to get the answer?
Yeah, if you had set it up the other way.
Or you could do like
Sure.
1 and 2.
We're going to do kind of the opposite of that, but
But maybe. But if you
Doesn't
have
matter.
like 1 and 2 over 2 over and 12 over 6, then 1 times 12 equals 12, but 2 times 12 equals 6.
sure. Yeah, and that's what we're going to do actually when we cross multiply. But that's what I mean. This is not the only way to solve a proportion, right? You might see something that's like if we had 1 over 2 equals 1 over c, you probably don't need to cross multiply that to know that c is 2. Right? We don't have that though. So cross multiplying is just a trick. That's all it is. It's just a trick that will help you get the answer. And that's how I'm going to do this one. Those other ways you guys said are totally valid as well. So my cross multiplication here is 24. And my cross multiplication here is just 1 times c,
Well, it would
which is just c. Right?
Yeah.
So do I have to divide both sides by the coefficient?
No.
No, right? It's 1c. Dividing by 1 gives you the same number. Do I have to reduce my fraction? I don't have a fraction anymore. So I'm just going to be done. When I have this alone, when I have my variable alone, that's when I'm done. Now since it's a word problem, give your answer in words. 12 apples would cost $24. this is another thing that I saw in the homework. You guys notice how many things I boxed on here? Try not to do that on your homework, because then I see like all these boxes, and I'm like, which one of these is your answer? Just box the final answer. And if you box something else for some reason, try to go back and erase it.
Well, what if you box the number answer and then you also box the word answer? Does that matter?
Well, if I don't see the word answer, then I may take points off, but hopefully I'll see it. Yeah, I mean, it's just, you're trying to catch my attention, you're trying to draw my attention towards something, so boxing it is a way that is helpful for me to find it. All right. We're going to do another example. Can I erase this one?
Yeah.
So, second example. Okay, it says the ratio of 7th graders to 8th graders in a spelling bee is 4 to 3. There are 18 8th graders. How many 7th graders? So this type of problem is a little bit more confusing in my opinion. And it's because they give you a ratio. So it's nice because you already have a place to start. I already have my ratio. Remember, this is the same as this. So they've given me one ratio. But if you start there, it's really easy to do your second ratio backwards. So you almost want to like take a step back when you see a problem like this. The first thing that we want to do is set up our word ratio. They said the ratio of 7th graders to 8th graders. That means 7th is first or on top, and 8th is second or on bottom.
So that is a map. He just created a map for you guys. Understand that? That's like key. That map then now is going to be what you're going to use for everything. Everything has to follow that map. Always got to have 7th graders on the top. Always 8th graders on the bottom.
Okay. And so then when they say 4 to 3, how many 7th graders are they saying in this ratio?
There are 4 something.
4. For every how many 8th graders?
3.
3. I'm not going to do this to you, but if you see a problem that says total, what would our total be in this case? How would you find that? What if it said there are 4 7th graders? How many students are there in total? I don't even know how you would do that. Looking at this problem.
Oh,
Yeah?
well, if it gave you 18 8th graders there, what you would do is you would find out what, how do I explain this? So, what I believe happened was they just multiplied 3 by 6. So what I would do is I would multiply 4 by 6, and then that would be 24 to 18, and then I would add that together, and then that would be my total students.
Yeah, that's the key. When they say total, total means add these two numbers together. Right? Whatever those two numbers are. What is the total number of students? Well, that would be the number of 7th graders plus the number of 8th. Okay. I won't do that to you yet, but just in case you see it somewhere. So we set up our first ratio. 7th graders on top, 8th graders on bottom. Our second ratio has to go in the same Order.
It would be.
Must have 7th graders on top, 8th graders on bottom. Right, I'm going to look back here. Okay, 7th graders. Well, look, it says how many 7th graders. So I'm going to use a variable. Let's use x. When all else fails, use x. And then 8th graders on bottom. So I'm looking back here. I'm looking over here and I'm seeing, okay, 8th graders. And I look at my problem. Oh, 18 8th graders. Okay, next step, reduce. There's nothing to reduce here. Next step, cross multiply. 4 times 18. I'm going to leave it like that. I'm just going to leave it as 4 times 18 equals 3x. So you don't actually have to multiply those numbers if you don't want to. You could, but if we wait, it's going to get a little simpler. Next step, cross multiply is done. Divide both sides by the coefficient. We want to know what x equals, not what 3x equals. If I divide this side by 3, and I divide this side by 3, over here, I'm going to have x left. 3 divided by 3 is just 1x. I'll have to write the 1. Now over here, I'm going to try to reduce this before I multiply it out. Because I noticed that 3 goes into 18. Did you guys know you could do this? You can have 2 factors in a fraction in the numerator, and you can reduce the denominator. This may be new for some of you. But I'm going to divide the denominator by 3, and then I'm going to just divide one of my factors here by 3. I'm going to divide 18 by 3, which is 6. All I have left now is 4 times 6 divided by 1. I can ignore divided by 1. So I just have 4 times 6, or 24. Is x. I'm going to look back at my problem. How many 7th graders? Okay, x is the number of 7th graders because it was on top of my fraction. So there are 24 7th. And this is my answer. Tomorrow you have a quiz. What did I not do on the board that I've been doing on the board that you should do on your quiz tomorrow? Check your work. Check your work. So once I get 24 equals x, take that, plug it in here. Right? Usually checking proportions is going to be very, very simple. Okay? Once it's plugged in, you'll probably see right away what you can reduce to solve that. Any questions about that? So I'm going to write down kind of my steps, what I would do when I see what I do when I see a word problem like this. So the process. Step 1 is to read the problem. Step 2, first thing you want to do is create your map, as Gary called it, right? Which is your word proportion. Or word ratio. Then follow the map to create 2 ratios. Set them equal. have two ratios that you set equal to each other, what is that? Two ratios equaling each other? What's that called? A proportion. Yeah. So you're going to solve the proportion. And if you forget on this step what to do, go back to that first map that you created. So let's do one more example. If you didn't quite get that, just look at your neighbors. All right. If 3 bakers prepare 15 cakes in 60 minutes, how long will it take them to prepare 20 cakes? Okay, so there's kind of some extra information here. And we have to pay attention as we read this. There's a number that we're not going to actually use to solve this problem. Does anyone see what it is already? Yeah. 3, right? 3 bakers. But it's the same 3 bakers later preparing the 20 cakes. So we don't really care about that number. All we care about is how many cakes they can make in how much time. Yeah.
1 hour and 2 minutes.
Okay, let's solve it on the board. You jumped right to the answer. So first step though, this is really important to think about. We're going to create our word ratio. And it doesn't matter which way we do it. Okay? All we have to see is that cakes and minutes are what we're comparing. We're comparing cakes and minutes. How many cakes can you make in some amount of minutes? But it doesn't matter which one I put on top and which one I put on bottom. Right? Let's put minutes on top. So if I put minutes on top, what goes on bottom?
Okay.
Cakes. This is my map. This is my word ratio. Okay, now I'm going to look at the first half. Well, we know in 60 minutes, they can make 15 cakes. And then we're going to be asked, how long will it take them to make 20 cakes? So 20 goes here, right? No? Why not?
The cakes goes on the bottom.
Because cakes goes on the bottom. It's 20 cakes. 20 cakes. So we have to line it up. What goes on top though?
Variable.
A variable, because I don't know how many minutes it takes to make 20 cakes. So I'm going to use M. Let's use M for minutes. I'm going to simplify, reduce my fraction. What goes into 60 and 15?
4, no. 5, 15.
15!
Yeah.
Woo! So we're left with 4 over 1 equals M over 20. I would recommend that you keep that over 1. Just because if you're going to follow that procedure, it's going to be more obvious how to cross multiply. So even though 4 over 1 is just 4, I would recommend you keep 4 over 1. Cross multiply. M times 1 equals M. 1M. M. All the same thing. Other side. 4 times 20, 80. I'm done. Write it in a sentence. Write it in a sentence. It will take 80. Wait, I thought someone said 1 hour and 20 minutes. Same thing, right? Questions?